Good afternoon, guys. Guys and gals, nice to see you all joining. Um, guess we'll go ahead and get started. Um, so today we're going to be talking about DevSecOps and how we can um, basically integrate cybersecurity into the application lifecycle. And let me go ahead and share my screen. So, going to get started by really just introducing Troll Security, how we got started, and then we'll jump right into DevSecOps. So, our main focus here at Troll Security is proactive and adversarial solutions. I founded Troll Security in 2019. Prior to starting Troll I spent about 3 years building out Command Center. That's our uh, main tool that we use. Originally was mainly was focused on pen testing management, but it's definitely grown a lot since the original inception. Um, During that time, I also spent those 3 years as an application security engineer at one of the largest health information exchanges. And my job there was to basically make sure application security happened within the life cycle. The only bad thing was I was the only guy and only person there. And we had about 150 developers. So uh, very daunting task. And I ended up doing a lot of automation, working with a lot of tools that they had. And then what I would do is come home at night and actually develop the same kind of structure, but without those tools, and built it using Python, Django, Golang, tools like that. So before Trolli, before even working for this enterprise, I spent about 16 years working for Cisco VARs, value-added resellers. Got my CCIE in 2007, and so my focus was heavily in network security, doing a lot of firewalls, IPS, WAF installs. Um, and while I was studying for my CCIE, I would test IPS solutions, mainly Cisco IPS solutions, making sure that they would actually work. So I started using a tool called, at the time it was Backtrack Linux. That's now Kali Linux. But I ended up kind of figuring out how to do exploitations through IPS because I wanted to make sure that it was actually stopping this stuff. And lo and behold, it actually didn't. A lot of, and that's when I kind of realized that Cisco wasn't much of a security company. Started using Snort IPS to test that, and this free IPS would actually stop attacks a lot better than the $40,000-$50,000 Cisco IPS. So, and at that same around that same time, I kind of uh, discovered that penetration testing was an actual career option. I didn't know it at the time, but it was, and so started kind of migrating into that field, learning how to use the pen test execution standards. Kind of discovered how the proper way of doing pen testing. Um, and so it was about 2008 when I really kind of kicked the network security aspect of my career off or out and started doing network pen testing. About 2010, I really wanted to become an expert pen tester, and so I learned how to build web applications, mainly because I realized when I was doing the network installs, everything that I was opening up to the web was applications, web applications, and so I saw at the time that that was going to be, some of the most vulnerable aspects of the organization outside of the end users. So I started learning how to build web applications, so I could understand it better and know how to actually attack them. Um, All of our pen testers and analysts, they're all heavily certified OSCP, OSWE, PNPT, GWAP, GPEN. Um, so that's from our organization perspective, we're very um, focused on um, being able to basically be the expert for your offensive security needs. At Trolleye, we have four pillars of cybersecurity. We focus on continuous penetration testing, dark web analysis, DevSecOps as a service, which is what we're talking about today, and one of the latest services that we've started offering is managed SIEM with a focus on purple teaming. Um, we have a lot of integrations using Command Center into things like AWS, Palo Alto, Fortinet, Cisco, Google Cloud, GitHub, GitLab. Um, a lot of the usual suspects that are within the development and cybersecurity range. So going back to 2016, when I was working as an application security engineer, I discovered that traditional cybersecurity testing, it was basically isolated, it was slow, it's a gated approach, and it definitely was not very agile. And so as I did research, as I tried to find better ways, better solutions to keep up with a growing development um, team and a very fast-paced uh, development cycles and sprints, I found that the solution really is DevSecOps. It's a more collaborative approach. It's shared, the responsibility of cybersecurity shared across the teams, um, reduces developer friction, and you're integrating cybersecurity into all the DevOps flows while also eliminating the wait states that are found in traditional testing. So let's look at some of the benefits of DevSecOps. So obviously finding vulnerabilities earlier in the pipeline and in the process is way cheaper than finding it in production. For instance, if you discover vulnerabilities during your design phase, in your coding phase, or even your integration testing phase, you're clearly going to be able to remediate those findings way sooner than if it were in production. When you find things in production, it generally takes a little bit longer to run it through the cycles um, of you know remediating these findings. So Gartner estimates that 70% of applications contain flaws that stem from the use of open source libraries. I'm sure you guys remember Equifax. Exploiting these flaws in open source libraries is a recipe for disaster at most organizations. So organizations that have adopted high levels of DevSecOps, they typically save an average of about $1.6 million over organizations that have not adopted DevSecOps during the course of a data breach. So what is DevSecOps? Well, DevSecOps is basically a culture shift. It's a methodology. It's integration and automation throughout the whole life cycle of the application. And most importantly, it's a partnership between the development team, the operations team, and the cybersecurity team. When you have gated cybersecurity, it really hinders the agility and it's incompatible with traditional DevOps workflows. What is it not? Well, first of all, DevSecOps is not a department. I've worked with companies that they'll have your dev team, then you have your security team, you have an engineering team, and lo and behold, you actually have a DevOps team too. It's like, well, that's a methodology. Why would you have a department dedicated for just a methodology when your whole organization is supposed to adopt this methodology? And it's not a tool, and it's not it's not gated cybersecurity. Integrating cybersecurity into the application lifecycle requires leaders to enable a culture shift within the organization itself. Uh, that way, the whole organization has responsibility and has skin in the game. So, where do you start? Well, assuming that you're working with an existing suite of applications, you really have to start with a baseline testing. Um, in this baseline security testing, it really must include authenticated and unauthenticated security testing to get 100% code coverage. It should also include static code analysis, software composition analysis, so you know where you're starting with. You know what you're working with, and then later on when you're testing, you only have to test the deltas, and we'll talk about that in a minute. Dynamic application security testing is typically involved along with manual application security testing when it comes to baseline testing with doing basically pen testing. So after you've got your baseline, you have an idea of what you're working with. You can start from there. You know what needs to be remediated, but then as you have more sprints, you want to include threat modeling during your planning phase. Threat modeling, basically you're building a document that's a living document, and you're going back to this time and time again. And as your application grows, functionality and inputs, those functions and inputs get captured, and the team gets to whiteboard the idea of what would happen, how could you exploit these functions. um, Threat modeling provides a summary of possible attack scenarios, and it outlines the flow of sensitive data and identifies vulnerabilities and offers potential mitigation options. Um, so the first portion is to build a system model. That includes your dev teams, obviously, because they know more about everything that has been put into this application, or they should. Second part is finding the threats. We typically use the STRIDE model, and that stands for spoofing, repudiation, information disclosure, denial of service, and elevation of privileges. Those are the key elements that the security teams are looking to find and answer the questions of. Then after that, you address the threats. What mitigations can we put in place? How do we stop an attacker or monitor uh, for this type of threat? And then next is validation model. Um, and you're really trying to find out, did we address the threats previously found last time? So if we look at an example, this is an example of a tool that we use called OWASP Threat Dragon. And basically it's a web interface, and you build out all the different functions and features, the models, the flows, everything. And then down at the left-hand corner, you see security controls checklist. There's only 3. Usually there's a lot more, obviously, in a real scenario. But here you're looking for, is this wallet, this is a cryptocurrency model. Um, is the wallet uh, encrypted at rest? Are the API keys using read-only access? And do you have proper authentication and authorization validation? So as you go through this threat modeling session with the development team, you find out that there is no authentication. It's not encrypted at rest, but the API keys are truly read-only access. And so you mark all these down, and then they get to go back during their coding sessions and actually make sure that this actually is true and it happens, and you mitigate these issues. So next during the planning phase is you address identity management. Kind of starts with data leakage. you're looking for, continuous threat detection, dark web analysis. Our dark web analysis is essentially really is second to none. We find usernames, passwords, session tokens, um, and that should be done on a continuous basis, constantly looking for new threats that are out there that would allow an attacker to potentially get into an application based on leaked information, leaked secrets. Um, you also want to try to prevent secret sharing and hard-coded secrets in the source code using tools like um, AWS Secrets or Google Secrets. Um, there's a number of different ways to make sure that you don't have secrets hard-coded in the applications and you're just calling that information when you need it in the live application. The next stage is to manage the identities and to enable least privilege. Really, it's just a need to know basis, right? Not everybody needs to know everything. And you do that with role-based access control within the application. We Okta, you can use uh, the built-in tools in Google, Azure. There's many different flavors of authentication that have a lot of these checks and balances built in. Next, you have password security. Obviously, MFA is not a silver bullet, but it sure beats nothing. Um, but you also need to set it up the right way, right? So there's ways to get past MFA as a pen tester. Um, if I can continuously push the button and tell it, check again, check again, check again, and that user is getting the notification, is this you? Is this you? Is this you? A lot of times they're going to go ahead and just submit, yes, this is me. Stop bugging me. That type of MFA is really, really bad. I think the best way to implement MFA is to use something like a token, a one-time token, one-time passwords, where only that user has the ability to put that information in the application and then get in. Um, Pen tester or threat actors can't get that information unless they actually have that phone, your phone, that token. Um, and then you have password managers, things like Keeper, OnePass, Bitwarden. Those are tools that are essential to allow your users to have because they create passwords that are really secure and then they store them. They actually implement them during live while you're logging in, and users don't have to create passwords. And I mean, I'll even throw LastPass in there. I know that it's kind of got a bad name now, but it sure is better than a sticky note or notes on underneath your keyboard, right? So the next portion of the planning phase is code standards, right? And that includes people, processes, and tooling. Fostering a culture of security among all stakeholders, from developers to IT operations and to project managers, is essential. You also have to have a security champions program for your development team. But a lot of times you can pick out those folks that are really interested in security that are on your dev team. Those people are very essential to having a good security champions program, and they can work closely with the application security team and kind of bridge that gap between security and development, and they can help accelerate the adoption of secure coding standards. Next are your processes. You really do have to have a secure software development lifecycle written down and implement the security features that are in the plan. And that should include obviously every stage of the life cycle. It should involve some level of security, whether it's development, testing, deployment, and then even maintenance. Um, Doing this allows organizations to shift from a reactive model to more of a proactive model as they deliver software solutions. Next is tooling. And I know security engineers, they love to kind of push these tools down developers' throats. And that's not really, that causes friction, right? Security teams shouldn't try to force the new tools on the development teams. Um, Once friction is kind of in place between development and security, it slows down the rollout of the new tools and slows down the process. So they really should be developer friendly and team focused tools, so everybody gets to play. So next is during the coding phase. Static analysis, software composition analysis, and I don't have it on here, but IDE integration as well. So as the developers are writing code and submitting code into to the Git repositories, they should be checked. It should be checked immediately for any introduced flaws or vulnerabilities. Um, they basically software composition analysis is very important when it comes to finding open source third-party libraries. This way you find out what's in the code, how can it be exploited, um, and we do a lot of these with webhooks and time-based. Um, so basically you get a webhook, then you spin up a scan, or maybe the developer has not made any changes on a branch in 2 weeks. That doesn't mean that code can't have become vulnerable. Something was found in third party. Well, that's where you add time-based checks. So every 48 hours, run another scan just to check to see if there's anything new that's been added or new introduced vulnerabilities. All right, next is the deployment or the deployment stage. As you're building these artifacts, you have to run vulnerability scans. It does require a working environment. So unlike static analysis, where all you need is code, you actually have to have a live system running to run dynamic analysis. And it's very important at this point to have known what changed from the baseline. Because the last thing you want to do is run dynamic analysis on the whole application every single time you build and deploy. That's going to take an extremely long time. So this is at this point we would work with the development team to produce an automated way to find out what has changed during the sprint, and that way you're only running vulnerability scans on the functions and the code, the user inputs that have changed. This way you find it quickly. Um, so automated unit testing helps you find this, as well as Swagger files. If you're testing APIs, Swagger files are great to have this is find these deltas. All right, so now you're in the testing phase. This is where the pen testing comes in, and the pen testers, they should have access to the dynamic analysis and the static analysis that was done previously. This way they can kind of do some targeted testing and vulnerability exploitations based on what has been found during those scans, and do this in a quick manner. Again, if you're testing the whole application, it's going to take a long time, and you're going back to that gated approach, which we don't want. Reasons why we do this during the release phase, you have compliance validation. A lot of frameworks, PCI DSS 4, SOC 2, State Ramp, they're all putting great emphasis on continuous cybersecurity. They introduce requirements for software security and vulnerability management as a whole. And they're actually implementing and requiring focus on supply chain attacks. That's where your open source and third-party libraries come in. So next is your deploy phase. So during the deployment phase, uh, code signing is very important. Kind of shrink wraps the packages and the applications, and even your container images. They have the ability to do software or to do code signing using cryptographic techniques, and it binds the image to a specific entity or organization. And this creates a chain of trust, helping establish ownership and accountability. Um, Trusted application stores like iOS and Google Play Store, they require code signing for any software to be distributed on their platform. So this is now we're into operations. Code is deployed, artifacts are built, everything is running live. Well, early detection is very important. By continuously monitoring systems and applications, organizations can detect security incidents early and then take immediate action to remediate them. Um, Incident response, real-time monitoring and analysis enables organizations to respond to security incidents quickly and effectively. By doing all this, you do get improved compliance. Now, as a security engineer, I'm going to tell you, so compliance does not mean secure. But when you do things the right way, you do things in a best practices manner, you end up with a secure model, and you will be compliant. And then lastly is improved visibility. When you're monitoring everything, you have all the right tools in place, you have greater visibility into all of the systems and all the applications, and they allowing them to identify potential security risks and to take proactive steps to address them. So during the respond, this is the last step, respond and recover. There's a variety of monitoring tools that are out there, techniques that are available. Log analysis, obviously SIM, WAF, that's a huge one. Heavily adopted as much as WAFs. RASP is essentially runtime security application or application security. It runs kind of in a almost in a pod in itself, protecting that application every single instance of it. Whereas a WAF, that's going to be outside to protect many different applications. IPS, the only way IPS is going to help you in any way is with SSL decryption, obviously. EDR and XDR, you're going to be getting a lot of logs. This is where all your SIM monitoring, SOAR is huge. You want to have that automated response. Now, can you automate all responses? No, and I wouldn't even suggest that you try. But automating as much as you can is a huge step in the right direction. Attack simulations and purple teaming, huge in this area. This way you know what your possible exposure is, and then you essentially can act on it, and it helps your SOC become better when you're engaging doing it in a purple teaming method. Dark web analysis during this phase, you're constantly checking for any new threats that may be out there, leaked data. Um, Very important, cyber insurance. Cyber insurance is key to being able to kind of cover your business liability for any data breaches that may happen. Um, they actually help you notify customers. They restore personal identities. They help provide monitoring for potential users that may have been involved in the breach. They help recover, and then they also help bring in professionals to repair damaged systems. Most states actually require companies to notify customers of a data breach that involve PII. So very important to get cyber insurance to help with that. And then incident response planning is huge. Being able to have a plan and to know what to do when it happens, um, it's a game changer. Because if something happens and you don't have a plan, you don't even know where to start, you don't have a team ready to assess, you're really just running around like a chicken with your head cut off at that point. So that's our presentation today. If you have any interest in taking your DevOps program to the next level, we definitely would love to talk and chat more. You can email me or call me directly. You can also email info@Trilleye Security. And then at this time, I know we're kind of running late on time, but we do have a little bit of time for question and answer. If anybody's got questions. I don't see any. All right. Well, it doesn't look like we have any questions. So I do appreciate your time. Thank you very much uh, for joining us. And feel free to reach out if you have any questions or just would like to chat more about it. Oh, I see a question.
Hold on, we got a question. How do we make our CI/CD pipelines more secured and robust?
So the best way to make your CI/CD pipelines more secure is essentially making sure that each step has proper security built into it, whether that's static analysis, and like I said earlier, knowing what the deltas are during a changed sprint or during the sprint, what has changed, then you can kick off um, a very targeted approach, vulnerability scan and analysis, and then make sure that you have, pen testers, security analysts looking at these results to make sure that they are legit. And if they are legit, then obviously you have to start the remediation process immediately, depending on severity levels and policies within the organization. Some organizations, they may have 24-hour turnaround on criticals. They may have a couple of days, really based on policies and procedures that are within your organization on remediation steps.
All right, we got another question from Miguel that says, how do I know when to start DevSecOps?
Well, so that's a great question. Obviously, if you are working in an organization that has DevOps and that has, traditional development teams, you should start. Um, I would also say though that it is not, um, it isn't only for teams that have development or organizations that have development. You can adopt most of these procedures and most of these processes within a standard IT infrastructure, um, and you will be better off and more secure utilizing a lot of the automation and testing approaches, even without development teams, because you still have infrastructure and third-party tools, third-party infrastructure that needs to be tested and monitored and secured.
Follow-up question from Miguel says, what are the points to evaluate that DevOps is ready to be to the next steps DevSecOps?
That's a great question, and I honestly not sure I know how to answer that because in my mind, if you have DevOps, if you're doing DevOps, then you should absolutely start DevSecOps. There's no reason to not include security within the whole life cycle of the application. There any more? Right, I guess there are not. So again, thank you very much for your time, and look forward to seeing you next time, and look forward to you reaching out and chatting. Oh, Is developing software a prerequisite? Absolutely not. Again, I do believe that you can implement the majority of these processes and methodologies within any IT organization. Um, doesn't have to be just software development teams. As a matter of fact, I would encourage you as an IT organization to implement threat modeling, to implement infrastructure as code, implement security testing on an ongoing basis. It's very, very important. All right. Well, thank you very much, and we'll look forward to seeing you next time. That's the question. Better. What do you suggest to get better at cyber or DevSecOps? As far as how to get, I guess get more involved and guess more knowledgeable about DevSecOps. Um, really, I guess that's just starting to implement it. The best way to learn is to implement. Um, I think starting to use tools like Terraform, Ansible, how to implement tools like Sneak or Synopsys within the pipeline. Trial and error is the best way to get better, for sure. All right. Thank you guys. Talk to you later.